Hey, hi there. So today we are going to talk about HOTP and TOTP. Most website today provides two layer of authentication. In the first, you have the basic authentication where you provide the username and password. In the second, you have multiple options. One of them is SMS, where you get a OTP on your mobile and you use that OTP as the authentication. Second is something which GitHub or Google provides nowadays. You have something like a push notification. So you get a notification on your mobile application to whether you want to approve this authentication or not. Third, which we are going to talk today, is the TOTP and HOTP. TOTP stands for time based one time password, and H hash based one time password. So maybe if you are aware of the Google Authenticator app or Microsoft Authenticator app, you can relate with this. If not, you have something similar structure like this. So whichever application you are trying to register or login in, they do provide a QR code which you have to scan with any authenticator app. This is basically an example of an authenticator app which I have made. I would be sharing the link of it. So yeah, when you scan your QR code with the authenticator app, you get something OTP depending on the type of the OTP. So this is an example of a time-based one-time password. You can see a time second here. So after the time second, the authenticator app would refresh the OTP by itself, and I can use this OTP to validate or with authenticate with my server. So before we get ahead with TOTP and HOTP, let's see what basically is behind the QR code. So in every QR code, you have something a URI it provides. The URI something looks like this. It starts with OTP auth, mentioning that this is for the OTP authentication. The next is the type of it. So you have a TOTP and HOTP. The rest things, you one of the main thing is the secret. The secret is something which the server generates for every user. So every user has some random secrets uh, that would be shared with the that should be shared with the authenticator app to generate an OTP. Next important thing is the algorithm, which algorithm we need to for the hashing. Uh, so there are multiple hash algorithms we have. One is SHA-1, 256, SHA-256, and many more. Like depending on which the server is using, that would be mentioning in the QR code. Digit 6. So how many digit of OTP required? So maybe some server would be requiring a OTP of 8 digit, but usually we go for 6 digit. And period in seconds. In this case, we have OTP of life cycle 30 seconds. So after 30 seconds, the OTP is not valid, or the authenticator app would be responsible to create a new OTP for the authentication. Now coming to the main part, which is the SOTP algorithm. So the flow looks something like this. As we talked before, we have an important thing that is the secret key. In HOTP, we have another thing that is the counter. So the counter in the previous URI we didn't have the counter because this was an example of TOTP. In TOTP we don't require the counter, while in case of HOTP we want something like a counter that is maintained by the server as well as the authentication app. So yeah, so we have the two things, secret key and counter. We feed this to HMAC. This is an hash-based message authentication code algorithm that would be responsible for hashing your secret with key along with the algorithm on the basis of the algorithm you mentioned. So in previously we had the SHA-1. So all these three things would be input for the HMAC function, and it would be generating a 20 bytes of hash code. This hash code would be the input for the dynamic truncate. We would be going into details of the dynamic truncate future in the further slide. So the dynamic truncate, the main responsibility of this is to reduce your 20 bytes of hash code into a 6 digit or whatever digit of OTP you require, and we get an OTP from the dynamic truncate and we send it to the user for the authentication. Same as for the TOTP, we almost have the same algorithm. Only difference is the timestamp. So as I have mentioned, in HOTP, the server and the authentication app both have to maintain a counter. So instead of maintaining that, there's something different in TOTP. In TOTP, we the C factor or the C variable is generated based on the timestamp. So the Unix timestamp divided by the X. X is like the time period. It can be 30 seconds or 60 seconds. So a general brief of what timestamp is, you can consider something like current timestamp divided by 30, 60, whatever it is. Again, the same thing. Rest are the same things, like we feed three things: the secret key, timestamp, and the hash algorithm to the HMAC, and it will give you 20 bytes of hash code. The dynamic truncate, the same functionality it did in the HOTP, it would be responsible for reducing it to n digit and giving you the OTP. Let's see a brief example of how it works. So I have taken example here. K, it's a random secret. It can be any string, but yeah, this is the string I had taken for this example. X 30, 30. This is the times. This is the seconds I want the OTP to be alive, and this is like a generic way I did a time step. This is more like a dummy example, but yeah, I am feeding this to the HMAC function. It gives me 20 bytes of code like this. Uh, so actually, it should be in binary format, but yeah, for simplicity, I have used in decimal. And the dynamic truncate would be responsible for generating a 31-bit binary number from it. Again, the same thing. This is the decimal representation of that 31 binary number. The dynamic truncate, since this is not of 6 or 8 digit, the dynamic truncate would be reducing it down to 6-digit OTP, and this would be sent to the user for authentication. Uh, Now looking on the dynamic truncate, which was the common and the important part in both the algorithm, uh, like the SHA-1 or the HMAC code we got from the previous step is given as input here, and after this step we have to find an offset. So the offset is like the last byte of the hash code, and we do a logical AND with 15. So why 15? The reason for 15 is that after this step we have to select 4 bytes from this hash code, like from the offset index. Suppose I get an offset of 19, then I am not able to select the next 4 bytes since I am out of bound here. I mean, if it is 18, 19, I don't have 2021. So to avoid that, I am doing an offset of I am doing a logical AND with 15. In this case, I have 249, which is my last byte, and logical AND with 15. It gives me 9. So from index 9, I would be taking next 4 bytes. In this case, it would be 115, 116, 13, and 109, and I would be left shifting it to make a 31-bit unsigned integer. This is an important thing. I need a unsigned integer since like I don't want a negative OTP number, obviously. But yeah, from this I get a 31-bit unsigned integer, which in decimal I get this number. Again, I have to reduce this to n digit, d digit. You can see this is the digit or the number of digits the server expects. So for that I have to take a mod 10 raised to 6 and finally get a 6-digit OTP number. So how does the server validates this? This algorithm works both same for the server and for the authentication app. But one thing is that in server you have a buffer or look ahead. What it means? Suppose you put your OTP just before, this is for TOTP, just before it expires, then technically think what will happen. So in that case, your server generates OTP for one step before and one step after. So it is able to cross check if your OTP lies in any of that span. If it does validate. Like it is kind of an exception you can see. Yeah, so this is how the HOTP or TOTP works. That's it.